see so many people trying to learn about things that I'm very passionate in my life, because over the last 20 years since I've been in the industry, I always try to not only learn things, but also teach things, some things that I learn. And it's great to see so many people being motivated in learning site reliability engineering. My name is Andy Grabner. This is a typical setting here for me. I'm in my kitchen, as you can see. And today is not about my kitchen. Today is really about showing you stuff that I think will help you as you're adopting SRE best practices. Now, let me start sharing my screen. As was mentioned, we will have dedicated time for Q&A later on. But if questions come up, feel free to use the chat feature in Zoom already. Type in your questions, or later on, I think we can open up the mics and then have a discussion. So again, if you want to follow up with me later, there was the LinkedIn group that was mentioned earlier. You can also directly connect with me on LinkedIn if you want to. Who am I? My name is Andy Grabner. I work for Dynatrace. Been there for more than 14 years now in the capacity of I call myself a DevOps activist, but really I'm a DevRel. So developer relationships. I'm the link between our user community that wants to know more about observability and building high-performing applications, and also with our product team. On the other side, I represent Keptn. Keptn is, since last week, a so-called CNCF incubating project. If you're familiar with CNCF, the Cloud Native Computing Foundation, that's the foundation that Kubernetes gave birth to, right? So it's the foundation that hosts projects like Kubernetes, Argo, Keptn, Helm, Istio, and many others. And we are now, and with we, I mean the Keptn community is also now a so-called incubating project. We made it from sandbox to incubating, and the next step is hopefully graduating. You will hear me talk a lot about Keptn because I really believe we built Keptn to make it easier for you to adopt and adapt DevOps and SRE principles around automation, but with a very special focus, which means putting observability into the driving seat, looking at monitoring data, observability data to then drive your automation. And this actually brings me to the first polling question. I want to launch the first poll. Hopefully this works well. The first poll, it just gives me a little bit more insights about who you are. And with you, I mean the attendees right now. And the first question is, what's the state of observability in your organization? Or if you're currently maybe switching organizations and learning something new, what do you think the observability status in companies you work with or for is? Are you monitoring every environment all the time? That means everything from production back to development. Do you only monitor business critical applications? Do you only monitor infrastructure? Maybe you just don't know, and that's also completely fair to say. I also understand that monitoring and observability are terms that might be a little bit loosely defined. What does it really mean to get observability? Can it just be an availability monitor that monitors if an application or infrastructure is available by doing pings? Or is it something where you may use what the industry has called for many years APM, application performance monitoring? Or do you do full stack visibility? Are you looking into open telemetry, Prometheus? There's so many cool things out there, especially in the cloud native space. So I can see now, it's great to get some answers here. It seems the majority is monitoring every environment all the time. This is great. I think this is what you want. You want to see what's happening at every step along the way from the application lifecycle. The next majority, the next bucket is we only monitor business critical apps. That's 33%. That's a third. That's great. As fraction is we only monitor infrastructure and one person doesn't know. That's also fine. All right, let me close this poll. There's going to be 2 more polls later on, but thanks for this. This is great insights. All right, so today, let me go and actually tell you what I'm going to talk about. The way I've structured my talk, kind of like in 3 acts. The first talk is, what is Keptn? What are the key use cases that we bring to you as SRE engineers, as DevOps engineers, as platform owners, or somebody that's just interested in it? And also, who is adopting Keptn? Because there's a lot of open source project out there. And therefore the question is this worth your while to look into it? Or is this just a kind of, we call it a kindergarten project, right? Where nobody, just people playing around. I'd show you that it's not just playing around. large organizations around the world are adopting it. The second act is, why did we build Keptn? Which problems does it really solve in a unique way? And why wouldn't you use just other tools for Keptn? And then the third act is going deeper into how Keptn actually works, the architecture, especially how you can extend it and integrate it with your existing tool sets, because Keptn is not replacing tools, as you will see, but Keptn is connecting your observability with all of the other tools that you're using in your organization, deployment, testing tools, notification tools, monitoring tools. It connects them all together to make sure that the systems that you're deploying are actually adhering to your SRE best practices, meaning that your systems are aligned with your SLOs. So, which brings me to the first act. What is Keptn? The best way for me to explain what Keptn is to actually take a quote from Taras. Taras is a performance engineer at Facebook. I think Facebook is a well-recognized organization. Taras has been at Facebook for many, many years. He's been involved in many large-scale and performance and scalability projects within Facebook. And he made a very nice quote. He invited me 2 years ago to speak at his performance conference. And he said, after he saw Keptn there, that Keptn feels like a reference implementation of Google's site reliability engineering and the site reliability workbook book. So I think that's actually a great quote from somebody that is living and breathing performance and reliability day in and day out at an organization like Facebook. But what does this really mean? Why did Taras come up with this quote? Well, because at the core of what we do at Keptn, we are using so-called service level objectives to continuously evaluate application and infrastructure to make sure that your apps and your infrastructure always stays within your desired state, typically healthy. Now, before I put out this animation to show you what this is and go into a live demo, I want to quickly switch to a second poll, because I actually want to know if you are, as an audience, familiar with the concept of SLOs, service level objectives. And I would like to know, are you familiar with it? Meaning, yes, you're implementing SLOs already, you heard about it, but you're not using it yet, or no, you've never heard of it, it's a completely new concept. That would be very interesting for me to know, because then I also know how much more details I need to give you in terms of explaining what SLOs are all about. So I'll keep this poll open for another couple of seconds, because I roughly have an idea on how many people voted earlier. So let's make sure that we get give everyone the chance to enter the poll. So right now it seems the majority has heard about SLOs. Some already implementing it, but I would say about 80% definitely know what SLOs are about. 20% don't know, never heard about it. So you will hear a lot about SLOs today. It is one of the one of the foundations of site reliability engineering. But that's great. I really like it that 20% of you saying, yes, you are already implementing SLOs. 60% yes, heard of it, but not using it yet. And hopefully I will inspire you today with the talk to use Keptn to start your SLO journey. All right, let's end the poll now. I think we're good. Got a good overview. So how does Keptn work? Keptn does a lot of things, but at the core, Keptn evaluates, as it says on the top, the state of your applications and also your infrastructure. It can also expand to your end users, anything that can be monitored with your observability platform. And the way you are telling Keptn what is a healthy system, what is a healthy app, what is a healthy user experience, we're using the concept of service level objectives. It's really simple. In Keptn terminology, what we have is we have a so-called lighthouse service. And you will see and hear a lot about our terminology, which is very aligned to what the Kubernetes community is using. So you will hear a lot about things that reference to nautical terms, like the lighthouse. The lighthouse is always watching out for you and is trying to give you clear passage into a safe harbor. So in Keptn, we also have a so-called lighthouse service. It's a core component when you install Keptn. And what the lighthouse service does, it looks at a config file, one of the configuration files where you, as the user of Keptn, as a site reliability engineer, for instance, you can specify what the objective is of your system to be considered healthy. You can see here as a list of SLIs, error rate, JVM memory, count DB calls, security critical. So that means you can specify, hey, I have a system that I'm observing, like the error rate of my system, the amount of memory that is used, the number of database calls we're making, whether there are any critical security issues. And you can not only specify that these are indicators that you're interested in, but you can also specify pass and warning criteria. So what do you consider the system to be in order for you to say that this is healthy, a healthy system, yes or no? So what Keptn does, it allows you to define your criteria, your objectives. Now, the question is, where does this data actually come from? The data comes from your observability platforms. We call them in Keptn terminology SLI providers. This could be data from Prometheus, from OpenTelemetry, or from tools like Dynatrace, Datadog, New Relic, SonarQube, Falcon, any type of tool that is observing the quality or the operational aspects of your system. And depending on which tool you're using and you're connecting to Keptn, you can specify how to query, how to extract things like the error rate, the JVM memory, the number of critical security issues, the database calls. So what you can see here are two examples. If I would use Prometheus as my observability platform, I would specify my individual queries using PromQL, which is the Prometheus query language, to query error rate, JVM memory, and so on. If you would use Dynatrace as a platform, you would specify the Dynatrace metrics expression, what metrics should be pulled in. So the point is, we have a nice separation of concerns here. On the top, you specify what type of objectives do you have for certain indicators, for certain metrics. And then on the other side, you specify how you can query and extract those metrics. And what Keptn does, Keptn orchestrates these two. It basically reaches out to these tools, says, hey Prometheus, I need these values, or hey Dynatrace, I need error rate, database calls, JVM memory for a particular app. Then these tools report back to Keptn the data, and then the Lighthouse service takes that data, analyzes every single metric, every single SLI, as we call it, against the objective, gives it a rating, green, yellow, or red, and then we calculate a total score on the top. Now, let me show you this a little bit in action, how this can look like. Or a good example of how I've seen people use this. In a very common example, how people start with this is they typically specify a list of SLIs, and typically they range similar to what we saw earlier, but maybe going now into a little bit more detail. They typically cover some performance aspects like response time, failure rate. That's kind of like how stable is your system, right? How many requests to your system that is currently processed are successful versus failed. Then you may have some specific critical transactions in your application that you're hosting. In this case, I've specified the login as a feature. And if you have a new version of your app, you may run some tests against it. This is why I call it test step login, measuring the response time of a new build, and also test step login number of service calls. If you think about it, if you're testing, let's say, a microservice or any other service that is providing your login feature, like an authentication feature, you might not only be interested in the number, in how fast it responds and what the failure rate is, but you might also be interested in how many backend service calls this service does, right? You try to authenticate, and maybe this service connects to a database to validate username and password. Maybe it connects to another backend authentication system. And you want to just monitor and see if the number of database calls or backend service calls kind of stays within what you expect. Last one, critical security vulnerabilities. I think we've all learned from Log4Shell that security is very important. So every time you get a new build, you want to also validate that you did not include any new security vulnerabilities. So with Keptn, you can specify a list of SLIs. Then remember, you specify your objectives. Objectives can be specified in two ways. You can either specify an absolute value, for instance, response time, the 95th percentile should be faster than 100 milliseconds in order to be considered good, or 250 milliseconds in order to be considered in the warning range. But you can also combine it with a relative threshold. So for instance, if you look at the test step login number of service calls, here I specify that it should be plus 0%, which means it should not increase by anything. It should not increase between builds. The number of service calls should be stable. Or to give another example, test step login response time, I say, I want it to be faster than 150 milliseconds, but also I don't want the response time to increase by more than 10% to my current release, for instance. So you specify your list of SLIs, your objectives, and then what Keptn will do, it will calculate a total score across all of these SLIs. And then you can specify what should be your total score to be considered a good build or a good health environment and a warning range. So you can specify overall score goals. So now how does this work in action now? If you have set this up, you can say, Keptn, I want you to evaluate my service that I've just deployed. Maybe I've built number one, and please, I just deployed it into an environment. I ran some tests, and now please evaluate, let's say, the time frame when the tests ran, last 10 minutes. What Keptn does, it reaches out to your observability platform, pulls in all the metrics, compares them. Remember, the Lighthouse service compares it against the thresholds, grades every single metric. And in this case, build number one, everything seems to be in the green range, which means we're getting 100% success rate. We get 100% total score, because by default, every individual SLI contributes, if it's green, 1/5 to the overall score, which is 100%. So everyone would contribute 20% maximum. If it is yellow, it would contribute half of what's possible, so 10%, and if it's red, 0. So let's assume this is great. Build number one is green. Developers bring you a new build, you deploy it, you run some tests, and then you say, hey, Keptn, I want you to evaluate build number two now. With the automated integration into your observability platform and the automated validation against your SLO, in this case, we could see, hey, response time and overall failure rate increased. So something is definitely not going into the right direction. We're getting penalized here. But most importantly, we have an architectural regression here, because the number of backend service calls from the login service that we're testing, which is very critical for us, went from 1 to 2 calls. So all of a sudden, a feature that has always made 1 call is now making 2 calls. And we have defined an SRE rule, a resiliency rule, where we say we don't want that number to increase, because there must be a really good reason why the authentication service, the login, all of a sudden makes more backend calls. So if this happens, then we're getting penalized, and we're only getting 50%, and we are directly passing this back to the developer, to your Git tool, to your Jenkins, to your GitHub action, whatever it is that you use currently in your automation tool belt to kick off a build, to deploy, and then you could kick off the evaluation in Keptn. The point is quick feedback. Quick feedback means developers can address this really easily. So maybe the developer says, I know what I did wrong. Maybe I need to update the library, or maybe to fix the code. So he fixes the code, gives you a new build. Performance is good again. He fixed the architectural regression, but all of a sudden, there is a security vulnerability that came in, because maybe the developer, in order to fix build number 2, he updated to a library, remember log4j, that has a known vulnerability. And in this case, this is no good either. So we're again getting penalized, not a good build. But fast feedback, if you integrate this into your CI/CD, you always monitor and you always observe and you always evaluate your desired state, which is it should all be green. So fast feedback, developer can fix it, build number 4 comes along, hopefully everything is green again. That's kind of the idea. Now, this was nice in PowerPoints, and I always say nobody believes if it's just PowerPoint. So this is why I want to give you a quick overview of my first demo of how this looks like. All right, so let me switch over to, this is Keptn here. So by the way, what is Keptn? Keptn, as I said, is a CNCF project. You need to install it on Kubernetes. Right now it is a, we have Helm charts, we have a Keptn CLI where you can install it on any Kubernetes cluster. We also have some tutorials where you don't even need a Kubernetes cluster, where we are creating one on the fly for you, and you can play around with it. But in general, when you have Keptn install, what you have here is the UI. We call it the Keptn bridge, because remember, Keptn is a captain of a ship that helps you to steer your apps, your services, your infrastructure into the safe haven of a green, always healthy haven. You can define automation projects, right? I have multiple automation projects here, and I want to focus on the release validation automation project because I want to, in my first demo, show you the core feature that everybody starts with when they're starting with Keptn. Keptn can do much more, as you will see later on, but at the core, Keptn does really well with automating the validation of your SLOs. So what you see here, I have a release validation project. I have a stage called production, and I have different services. Services could be my applications, could be a microservice, could be a monolith, anything, any name. We just call it service. And every time I have a new build, and maybe I deploy that build and I run some tests, either manually or automated, then I want Keptn to evaluate my quality. So what I've done earlier, as you can see here, just before I kicked off the webinar, I kind of kicked off Keptn. Actually, let me kick off a new sequence so that you can see how easy this is. So I can say trigger sequence. I can say I want to do an evaluation for I have 3 services here. I'm using this one in stage production. Then I click on next. Now I can specify what type of time frame I want. I just go with a standard time frame of 30 minutes. That means I'd say, Keptn, my application has been running for 30 minutes. Now you please evaluate it. You can also give a start and stop, but you can also give timeframes, whatever you like. You can also do some labels. Build IDs, and one is a very specific one. 1, 2, 3, 5, I think is the one I need to use, because this will later show up nicely in the UI. You can also do executed by Andy during GSTC webinar. And then I could also say something like, I don't know, external link. Let's assume I'm not kicking this off manually, but maybe I'm doing this through the API, and maybe I'm kicking this off from your Jenkins, your jenkins.yourorg.com, right? And it could be your pipeline. So you can specify here name value pairs. We call them labels, and they allow regular strings or also links. Now, if I trigger the sequence, what you will see, if everything goes according to my plan, Keptn is now triggering that sequence. Remember, the Lighthouse service is doing its job. It is looking at the SLO definition that is behind the scenes in a Git repository. I also get to see build 1, 2, 3, 5 executed by Andy. These are all the things, external link. Also what Keptn does in my case, because I'm using Dynatrace in the background, it is pulling that data in. Now, in my case, from a Dynatrace perspective, we have a special integration with tools like Datadog and Dynatrace and Prometheus. For Dynatrace, for instance, you can actually specify a dashboard. So what you see here, this is a dashboard that I've created in my observability platform. And this is kind of the definition of my SLOs. So I can either do it in config files, as you've seen it earlier in my slide deck, but with a more visual approach, you can also just specify your dashboard, and you put your thresholds on these charts. And then really what Keptn is doing with that integration, it is pulling in the data from that dashboard and comparing it against the thresholds that are also specified on that dashboard. So this will probably take a minute or so. I can go back to a previous execution just to show you how this looks like. And I can also go back and see all of the results, right? These are all the results that came in. Here we go, 1, 2, 3, 5. I think that's the one I executed. You can also see the actual values that were pulled in. So for every metric that I specified, I get to see the value that was pulled in, the change maybe to the previous build, and so on and so forth. And also how every metric, every SLI was compared against the criteria and what the score was. Now you can also see something interesting here that I didn't mention earlier. You can specify weights. So by default, every metric, every SLI is weighted equally, so contributing equally to the total score, but you can also change it. You can say a certain metric, a certain SLI might be 5 times more important than others, right? You may have different criteria that, let's say, memory usage or performance is more important than something else. You can also mark certain metrics, as I see here in bold, as a key metric, which means if this metric fails, it basically overrules the final result. A good example would be if your key criteria is to not introduce any new vulnerabilities. You can say the vulnerability metric is a key criteria. the best performance, the best stable system is no good if it has vulnerabilities. In my case, I have the AppTex specified as a key criteria. AppTex is the so-called user experience index. I want my users to have a great experience, and my monitoring tool like that observability tool Dynatrace can do this for me. Now let's go back. Let's see my previous execution. You can see here it just finished with a score of 81. That's great. I can see it here. Now in my result, I got 81%. That's awesome. What I also have, and this is the nice thing about Keptn, and you will learn more about this as I go into the architecture. Keptn is an event-driven system, which means I've also configured to push events when Keptn finishes an evaluation, for instance, to an external tool like Slack. So you can see here 4 p.m., that's my local time. I pushed the event over with the final result, and everything is here. Right? So Keptn is very flexible here. Keptn itself is an event-driven system. These are all events. Evaluation, get SLI. There's always a started and a finished event. And later on, you will see that you can also subscribe to those events and push it to external tools. Keptn is really connecting all of the tools together. All right, so this is kind of my first kind of demo. And the idea is trigger this from any of your existing tools, whatever tools you currently use to build, to deploy, then you can trigger it directly from there and then get the result back to your system. The other option that you have, if you're not fully automated yet, you can do it like I did. I just manually clicked on trigger evaluation and then I got the result back, even pushed to my Slack once the result was finished. All right, so the bigger picture, I want to talk about the bigger picture because there is always a bigger picture because this is just the start. Really what we do with Keptn is much more. Now we're putting SLOs into the center where you can specify SLO service level objectives to really describe your, I call it almost the business desired state of your apps and infrastructure, because that really means you always want your system to be green, right? When a new build comes in, you want to make sure that new build only makes it into production if everything is green. And you also want to make sure it stays green in production. So with Keptn, you can define the SLO. Keptn itself gets triggered and becomes active based on two type of events. Either if you have a new build, or let's say a GitOps change event, you're using Argo CD, Jenkins as a new build, and you want to make sure that new build gets tested, evaluated, or if a production alert comes in. Let's say you are Prometheus, you have an alert, or your Dynatrace, your Datadog, it detects a problem. It can also trigger Keptn and say, hey, Keptn, we're currently out of our SLO. We need to do something. Now, what does then Keptn allow you to do? It can react to those events, and it can do two major use cases. One is it can orchestrate a sequence of tasks, as we call it, to deliver the promotion of an asset. So if you have a new build, if you have a new container, a new version, Keptn can be used to assess the situation before deploying, then instruct the deployment tool like Jenkins, Argo, GitLab to deploy. It can also then instruct tests to be executed and then afterwards validate if everything is still green based on the SLOs. If everything is green, it can promote. Otherwise, it can stop the promotion there or even roll it back. So Keptn on the one side can orchestrate delivery promotion. The other major use case is it can orchestrate what we call day one and day two operations. That means if something is wrong in production and you get an alert because your SLOs are violated, so let's say your Prometheus sends an alert, then Keptn can orchestrate what we call a so-called remediation sequence, where it can assess the situation about the problem that was reported. And based on the assessment details, right, collecting more information about your SLOs, deciding what action to then trigger. Maybe it can then trigger another pipeline to roll back if it's a bad build, scale up, scale down. Afterwards, it always validates, again, if the system is back at a healthy state. And it can do this in multiple iterations. You can specify multiple tasks that Keptn should trigger. If it goes back to green, that's great. Then the problem is solved. If not, you can escalate at the end. The point though is, so we're putting SLOs in the middle, we're getting it from the observability platform, and then we can orchestrate sequence of tasks that are triggered by events, like a new deployment is available or a problem in production. Most important, and this is a mistake that I made in the very beginning when I talked about Keptn, Keptn itself does not deploy. Keptn itself does not test. Keptn itself does not monitor. Keptn orchestrates and connects to your existing DevOps tools, because you have great tools out there that can do these individual jobs pretty well. But what we are doing with Keptn, we are putting your observability tools into the center, and then we are connecting your automation sequences that you can specify in Keptn with your existing tools to let them do their job when the job needs to be done. And the way we do it, we're doing it through an open source standard. This is another great benefit of being an open source project. We are driving an open source standard to connect tools to an orchestration tool like Keptn. We are using so-called cloud events. It's a project in the CNCF. And on top of cloud events, there's a new project called CD events. CD stands for continuous delivery. And we already have a bunch of these tool vendors on board that they are implementing this particular standard. Why do we do this? Because we want to avoid that we have multiple tools, like multiple deployment tools, multiple testing tools, that basically do the same task, but they all have a different API, a different way how to automate them. And we have understood that this is a pain point right now in building automation and building orchestration to connect all of these tools, because they all have proprietary APIs. So through the open source community, we're standardizing the way we're communicating with these tools and let them be part of an automation sequence. That sequence is triggered and centered around SLO stop, because in the end, you always want to make sure that whatever build comes in, it is green based on your SLO specification. And in case something happens in production, you want to bring the system back to green. Kind of your SLOs are kind of like your North Star, your business desired state. All right. So as I mentioned earlier, you can trigger Keptn for many tools, and it can then also orchestrate many other tools. And this is just what I want to show you in a second, quick use case. So let me go back to my example here. Release validation. I have a different project here that's called delivery demo. Before I show you this, I want to show you behind every project, we have a Git repository that contains all the configurations. So when you start setting up a project, the first thing you need to do is you need to specify Git repository. You need to specify what we call a shipyard file. I will go into shipyard in more detail in the rest of my presentation, but this is where you specify what we call sequences. There's a delivery sequence and there's certain tasks. You can have multiple sequences defined that have different tasks here. And you can also connect them, like have a production stage with a delivery sequence that gets triggered if other sequence is finished. So this also allows me to do multi-stage delivery. So if I go back to my Keptn project now and into my, let's say, my delivery demo, or actually let me go to my rollout demo, that's even more interesting. Here, what I have is when I push a new build in staging, you can see here, Keptn is actually doing a so-called delivery sequence. And then it's doing Monaco. It configures my monitoring system. Monaco stands for monitoring as code. Then it triggers a deployment. This could be Helm, for instance, or it could be Jenkins, anything. It validates if the system is running. We have an integration here with Argo, where we are letting Argo actually do a blue-green deployment or a canary deployment. And then we do the evaluation. Then we even have an approval in the end where I can ask the user for permission to really then promote this build here from my staging environment that was just evaluated by Keptn with 100% into the next stage. And the next stage for me here is, if I go to the top right, is production, right? And in production, you can see here I have a delivery, canary phase 1, canary phase 2, canary phase 3. We're doing even a canary rollout orchestration when every phase, we are basically allowing Argo to do a rollout of the next canary set, then run some tests, some low-cost tests, some JMeter tests, whatever testing tool you have, and then the evaluation. So you can see here, Keptn can do much more than just evaluating. You can specify sequences of tasks and you can trigger them either when you have a new deployment or when you have a problem in production. Then Keptn can also orchestrate sequences and can then talk with the tools and get them in there. All right, demo number 2. Now, quick thing, who is adopting Keptn? I want to just tell you that we're not the only ones that talk about and have demos. We have a lot of people adopting Keptn for the evaluation of a new release. And very often we see it in combination with automated testing. For instance, like Mike is doing here with automated performance testing. We have a YouTube channel as well, a Keptn YouTube channel, so you can see all of these recordings. Point here is Mike is using Keptn to automatically analyze the results of his load runner tests that he runs for every build, saving him a lot of time because he doesn't have to manually now analyze the results for him. He's using the same dashboard-based approach that I've showed you earlier. Keptn analyzes it, gets a feedback back. The next use case, and this is very dear to my heart, I live in Austria, center of Europe, and one of our first adopters was Raiffeisen Software. They are building the software for most of the Austrian banks for the online banking. And what they are doing, again, they're using Keptn for the evaluation capability. For every build that gets built by Jenkins in their case, right? Once Jenkins is done with the building and the deployment and running, I think, some Selenium tests, they're then calling Keptn and say, please, Keptn, now you go off and evaluate the results and then give me a score back to Jenkins. Another example, which I also like a lot, is kind of like the multi-stage orchestration process, like what Volution is doing. They have Git that is pushing the pipeline that is then creating an artifact in JFrog, and then Keptn takes over when the new artifact is available and is then orchestrating a multi-stage deployment by integrating or triggering all of these tools, using Argo for what it's great for, that's deployment, using JMeter, what it's great for testing, using Dynatrace, what it's great for monitoring, and then Keptn is orchestrating everything. Last use case I have here from a user is from P&G. They are using this for auto remediation. So they're getting alerts from the observability platform, and then they use Keptn's capability to specify so-called remediation sequences, where you can specify for what particular problem that is reported from a monitoring tool, what type of action should be triggered. And in their case, they are triggering Python scripts. And the most important thing is Keptn is then always evaluating after these actions if the system is back at a healthy state. And that's it. So why did we build Keptn? I think this is, hopefully you understand now what is Keptn, but the question is, why did we build Keptn? We built Keptn because, well, clearly, if you look at it, you could do this all of yourself, right? You could build an orchestration and automation platform that, let's say, uses Jenkins or any other tool, because there's so many great automation tools out there. You could build this all yourself with custom coding, custom scripting, but then you also need to take care of connecting all of these tools that you want to integrate in that process, like your testing tool, your deployment tool, your notification tool, your security scanning tool, and so on and so forth. You can do all this, but you need to maintain all of these automation scripts and also these integrations. And we've seen that this sometimes becomes really challenging. Like one of our early adopters, Christian, he was also building all of these automation scripts with his tool of choice. And sometimes these automation scripts became more complex than the microservices that were actually deployed and tested. And he didn't do this just for one pipeline, but he did this for almost 1,000 CI/CD pipelines. And this is just challenging. Also, we internally at Dynatrace, the reason why Dynatrace is behind Keptn is because we also ran into the same problem that our existing pipelines that we used, while they were great in the beginning for our monolithic applications, as we were moving to microservices, every application team had their own little requirement for what tools to use for a particular task. So they all started off with a template pipeline, but then made their own modifications. So we ended up with a lot of different permutations, a lot of copy and pasting. And in the end, we had a lot of duplicated code and code complexity in our pipelines, which were very hard to maintain by people like Dieter. And this is why we said we need a new approach to automation in the cloud native space, because the old approach just means a lot of technical debt. So my conclusion is the left one is what we do today, but it doesn't scale, because eventually you need a lot of people that maintain pipeline scripts that become very monolithic and very hard to keep them from breaking. And so we thought we need a new approach with Keptn. So how does Keptn work? I think you've seen it, but I want to explain it again in a little kind of architecture overview. First of all, if you want to get started with Keptn, check it out. Go to keptn.sh or to the Keptn community. But initially, the problem, how we came up with what we have, is really what you saw earlier. We saw that internally and with many of our users, we had pipeline scripts or automation scripts, classical automation scripts like Jenkins and others. These are great tools, and we don't replace Jenkins, but I think it's time to rethink of for what we use these tools for. So we've seen, like with the Christian example earlier, automation scripts that were more than 1,000 lines long because they had hard-coded integrations and tasks, prepare, calling a tool, deploy, calling a particular tool with a very specific integration. So what we said, instead of having everything hard-coded in one big automation script, we need to remove those dependencies. We need to allow you to separate the process from the tooling and the configuration. So now in Keptn, you can specify on the left the sequences that should be orchestrated when a certain event happens and you build this there, or and the problem happens in production. On the right side, you have your tools. You may have one monitoring, you may have multiple monitoring tools, you have different testing tools maybe. Then we want to make sure that no configuration lives somewhere hard-coded in an automation script, but stays somewhere version controlled. And then we connect all of this again together using eventing, which is the same thing that software engineers do as they're breaking monolithic applications into more service-oriented architectures, where they have individual services and they chain them together to fulfill business processes through events and event subscription models. So to give you an example, Mike, the first example I showed you earlier from a real user, performance automation, evaluation. So he has a sequence that's called performance and does a deploy of an artifact, a test, and then the evaluation. So what he can do is, if he has set Keptn up like this, he can say, Keptn, I want to trigger the performance sequence because I have a new image, my app version 2, in staging. So what now Keptn does, it goes through that sequence definition. It says the first task in there is deploy. So what Keptn does, it sends out a standardized event and says, I need a tool that can deploy this particular image in a particular stage with, let's say, a particular deployment strategy. And you can see here through the arrows, through the lines, that you can have one or multiple tools subscribe to those events. Why would you have multiple tools? Well, first of all, you can pick your deployment tool of choice for that particular environment to say, I take the deployment job. But you may also want to push the notification about that deployment to Slack or to an email, whatever it is. So you can subscribe to the same events. And then every tool can decide if it has an active part in it, doing a deployment, or maybe just notifying people. As the deployment is done, Keptn goes to the next task, it's test, and does the same thing. Sends out a request to say, I need a tool that can do a test. You may have a testing tool, does the test, any external tool will do. And then at the end, there's the SLO evaluation, and you've seen this earlier in the demo. It will send the get SLI, pulls the data in from the monitoring tool, the lighthouse does the evaluation, comes up with a score, and then everything is good. So terminology perspective, we're talking about a shipyard file. We're talking about the uniform. This is the tools that are taking part of an orchestration sequence. Then we have the config in the config repo, and then we have cloud events here. Right? And I hope this makes hopefully a lot of sense for you. Now, I am also conscious about time because I want to make sure that you guys you get all of the time to also ask questions. Now, let me go into what I've explained to you is, I think what we're doing is we're bringing opinionated cloud native automation to all of your projects. While Keptn itself runs on Kubernetes, it's an event-driven system that allows you to get rid and reduce the complexity of your existing automation and orchestrate it for you. The key point though is we are bringing and putting observability, SLOs, this is the core concept of site reliability engineering, into the automation. We always make sure that your systems are operating the way you want them to operate, that they're always resilient, and therefore we look at SLOs. And you can either, I always say, you can either take the left, the red pill, or the blue pill, or the green pill, whatever the matrix from the movie, the analogy is, right? And I also have a more management-friendly slide version on this, same thing, but you can either decide to spend a lot of time in maintaining your pipelines as they are, or you can have a look at Keptn. Now, most people start with integrating SLOs into their existing pipeline, as I said, right? If you have an existing automation tool already, like Jenkins, like GitLab, Harness, you can see all the names up there, and you already deploy and maybe you already run some tests, then start with using Keptn for just the SLO evaluation. But if you want, Keptn can do much more, right? It can automatically execute your tests as well, or trigger your testing tools. And you can integrate with a bunch of different tools through different means. You can also build your own integrations. Now, before I open it up for questions, I want to also say thank you to Dynatrace for driving the innovation, because they have been doing this obviously for their benefit, so that their internal development teams have a better way of deploying and managing automation. But I'm really happy that they were contributing this project to the CNCF for the greater good of the DevOps and SRE community in Cloud Native. With this, I truly hope that what I said made sense, that you saw a little bit of Keptn, and now I would like to open it up for Q&A.